All right, we are on to example 7. This is the absolute last example problem for section 4.4. So let's go through this together. Descartes' rule of signs first, because I want to know what I'm looking for. Positive roots. We have a sign change here, sign change, and another sign change. So there are 3 or 1 positive real roots. Remember, we reduce that by an even number. So if you can subtract 2 from it, you do that until you can't subtract 2 anymore because it would result in a negative number. All right, then we're going to find how many negative real roots we've got. So I'm going to take negative x and substitute it in the place of x. All right, when I sub in and simplify, I have x to the 4th plus, so positive changes here to be negative, but then it stays negative right here, so 1 sign change. There is 1 and only 1 negative root. So there's either 3 or 1 positive roots, 1 negative root. So then we're going to do our non-reals. And our degree this time is 3. So hopefully it's obvious at this point. Oh wait, can I not count here? No, sorry, degree is 4. I don't know what I was looking at there. Degree is 4. If there are 3 positive roots and 1 negative root, that already adds up to 4. So there'd be no non-real roots. If there's only 1 positive root and 1 negative root, then there would have to be 2 non-real roots. All right, factors of P and Q so that we can start narrowing down our list for guess and check. All right, so P is negative 28, so my factors are plus or minus 1, 2, 4, 7, 14, and 28. Q is 1, so that list of the factors of P, that is an exhaustive list of all possible rational factors of this polynomial. That does not mean that we couldn't have some irrational but still real roots, and we'll talk about that here in just a minute. So I'm going to substitute in 1, so that would give me 1 minus 6 plus 3 plus 24 minus 28. I'm going to add that up, negative 5, negative 2, 22 minus 28, that's negative 6. So no to the positive 1. Try negative 1. That would be 1 plus 6 plus 3 minus 24 minus 28. Absolutely no way. That is 10 minus 24. So negative 14 minus 28, I get negative 42. So plus or minus 1, not going to work. Try the next one on the list. Let's do 2. F of 2. 2 to the 4th is 16 minus 6 times 8. So that's 48. I'm just going to rewrite that as 48. Plus 3 times 4, so 12. Plus 48 minus 28. Well, I see right here that those 48s are going to cancel. 16 plus 12 is 28. 28 minus 28. Here is a 0 of this function. Time for some synthetic division. So my 0 is 2. I should probably start a list. My solutions, my roots, my zeros, whatever you want to call them. We know that 2 is on that list. All right, so coefficients. 1, negative 6. 3, 24, negative 28. Make sure I have every single power of x represented before I get into this, because otherwise it's going to throw me off and I'm going to have a mistake. 4, 3, 2, 1, and then my constant. Yep, so I'm going to do my synthetic division. All right. Coefficients I got were 1, negative 4, negative 5, and 14. So this down here means that I have x cubed minus 4x squared minus 5x plus 14. Here, let me move this out of the way just a little bit. All right. So I'm going to find a new p and a new q here because I still have x cubed. Can't factor that yet. I'm only looking at factors of 14 now. This is my new p. And q is the same old, same old. That leading coefficient is not going to change. And just like before, because of that leading coefficient being a 1, the factors of my new p are all the possible rational zeros here. We already tried plus or minus 1 before, and so I don't need to try that again, because if it did not give me a 0 of my original function, it is not going to give me a 0 of one of its factors. We found that 2 was a factor. It could be a double root, so I am going to go ahead and try that one again. We're going to see if this is a double root, and I'm substituting in, of course, to this guy right up here, not back all the way to my original one. So I would have 8... see, minus 8 looks promising. Minus 10 plus 14. Okay, so that worked there, but I'm going to get a positive 4, so that did not work. Let's try negative 2. Maybe we'll have better luck with that. So I'm going to have negative 8. This is going to be plus 8. Plus 10, plus 14. There's a mistake. I actually made the same mistake right up above. See if anybody caught my mistake. I'll give you a minute. It was right here in this second spot. So 2 cubed, yes, that's 8. 4 times 2 squared, so I have minus 4 times 4. So this is going to be minus 16, not minus 8. I got that wrong. Sorry, guys. So I would have negative 8 minus 10, that'd be negative 18. Negative 18 plus 14, I get negative 4. So now I'm going to substitute negative 2 in, and I'm not going to make the same mistake. So I would have negative 8. I'm still going to have minus 16 here. This is going to be plus 10 plus 14. Negative 8 minus 16, that's negative 24, and I have a positive 24. Here's another 0, so I'm going to add that to my list. So I also have negative 2 on my list here. And now we're going to do some synthetic division. I'm going to bring that up and around over here. So negative 2 is my 0, and my coefficients are 1, negative 4, negative 5, and 14. There we go. Let's do that synthetic division, and then I'm going to end up with just something that's been squared. So I'm either going to be able to factor that or use quadratic formula. All right, synthetic division. I end up with 1x squared minus 6x plus 7. Let's see if that's going to factor. I need two numbers that when I multiply them together, I get a positive 7. That's a pretty short list. It's 1 and 7, or negative 1 and negative 7. Adds to negative 6. So if I do 1 and 7, that multiplies to 7, but that adds to 8. If I do negative 1 and negative 7, that's going to multiply to 7, but add to negative 8. So this does not factor. That means quadratic formula's away. So x equals negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. So that would give me x equals 6 plus or minus the square root of 36 minus 28. Not going to be imaginary zeros here, because that's going to be a positive number underneath that square root. Let me scoot this just a little bit by myself, just a little bit more room here. 36 minus 28, that is 8. So I have x equals 6 plus or minus the square root of 8 over 2. There's a perfect square in there. 6 plus or minus 2, square root of 2 over 2. Oh my goodness. All right. Again, because this is 4 times 2, I can do that. I can reduce this. Don't forget you got to reduce both pieces here. So I'm actually going to rewrite that, I think, as x equals 6 over 2 plus or minus 2 square root of 2 over 2. I feel like I keep running into some problems there. Not with my solution, just with my spacing on the page. I'm trying to avoid having things covered up by the writing that insists on showing up at the screen so that you guys can see all of this. All right, so when I do that, that would be x equals 3 plus or minus the square root of 2. So there's my other solutions. I'm going to scoot that over just a little bit. There we go. So right there's the other solutions that I'm looking for. They're not complex. Well, sorry, they are complex. They're not imaginary because there is no I there, but they are irrational. The square root of -2 is irrational. And even though we have the plus or the minus, if you do 3 plus square root of 2, you're going to get a positive root. 3 minus the square root of 2, remember, square root of 2 is just a little bit smaller than 1.5, so that's still going to be positive. So when I look back at Descartes' rule of signs, it is this option right here that ends up being the case for this polynomial. We got 3 positive real roots and 1 negative real root.